Hello, welcome to Fundamentals of Acoustics. Now, we will extend this discussion further. So, here we had two sources. Now, let us see what happens when I have four sources. For four sources. So, first let us define the problem. So, I have four sources S1, S2, S3, S4. The distance between each of these is d over 2. And then there is a median line, and these sources are S1, S2, S3, S4, and these are the distances. Okay. And I am interested in finding the pressure at a far field point. So, from S1 the distance is R1, from S2 the distance is R2, from S3 the distance is R3, and from S4 the distance is R4. Okay. And if I connect all these points, then the distance from the median line to the point of interest is R, and this angle is theta. This angle is theta. So, here we say that volume velocity magnitude of VV1 is same as volume velocity magnitude VV2 is same as magnitude VV3 is same as magnitude VV4 is same as some common number VV, and also phase of S1 is equal to phase of S2 is equal to phase of S3 is equal to phase of S4, and this is equal to 0. Okay. So, for such a situation, first we will write down the expressions for R1, R2, R3, R4. R1 is equal to, so again how do I calculate R1? I drop a perpendicular, and so this is first assumption, second assumption is phases are 0, and the third assumption is R is extremely large compared to d by 2 or d. Okay. So, given the third assumption, we can say that R1, R2, R3, R4 all these vectors are parallel to each other, and the relation between R1 and R2 and R3, R4 is something like this. So, because of 3, R1 equals R minus 1.5 d sin theta, R2 equals R minus 0.5 d sin theta, R3 equals R plus 0.5 d sin theta, and R4 equals R plus 1.5 d sin theta. So, the pressure at point P, which is P is a function of R, theta and T, will be the sum of pressures from all these four individual sources. So, the contribution from each source is VV divided by 4 pi R times j omega rho naught times E j omega t, and in the brackets it is going to be E minus j omega r1 over c plus E minus j omega r2 over c plus E minus j omega r3 over c plus exponent minus j omega r4 over c. Now, in this relation we substitute expressions for r1, r2, r3, r4, and we can take r outside the bracket because it is common. So, what I get is p r theta t is equal to V v divided by 4 pi r j omega rho naught E j omega t minus r by c, and in the brackets what do I get? I get, so if I define, so if d sin theta over c, omega d sin theta is equal to alpha, if I define it like this and I plug this relation and these relations into this overall equation, then what I get is e to the power of j 3 alpha plus e to the power of j alpha plus e to the power of minus j alpha plus e to the power of minus 3 j alpha. So, this is equal to, so this is defined as A, and in parenthesis, so I will reorganize this. So, I will call it exponent j 3 alpha plus exponent j 3 alpha, but there is a negative here, plus exponent j alpha plus exponent minus j alpha, and what I do is I again multiply and divide it by a common term which is E j alpha minus E minus j alpha divided by E j alpha minus E minus j alpha. So, when I do the multiplication, what do I get? There are 4 terms here, 1, 2, 3, 4 in the larger bracket and 2 terms in the smaller bracket in the numerator. So, I will get 8 in different terms, and if I do all the mathematics correctly, what essentially I get is, so e to the power of, so first what I will do is I will multiply this by this entire thing. Okay. So, what I get is e to the power of j 3 alpha times j 4 alpha, j alpha is exponent j 4 alpha, and then when I multiply 3 alpha, no, minus 3 alpha with minus alpha, I get minus exponent minus j 4 alpha. Okay. And then I get, if I multiply 3 alpha with minus alpha, I get minus E j 2 alpha, and if I multiply this j alpha with j alpha, I get E j 2 alpha. Okay. And then I get, if I, okay, let us step back a little bit, otherwise this will be too fast. So, I have multiplied E j, okay. So, this is 4 alpha minus e to the power of minus j 4 alpha. Then when I do the other multiplication, I get minus e to the power of j alpha minus e to the power of minus 2 j alpha, and then I get a third bracket which is e to the power of j 2 alpha minus e to the power of minus j 2 alpha, and then finally I get 1 minus 1, and in the denominator I get e to the power of j alpha minus e to the power of minus j alpha. Okay. So, in this 1 cancels out, this e to the power of j alpha cancels out with this term, and this term cancels out the other term. So, I am left with a j sin 4 alpha divided by a j sin alpha, and of course there is 2 there. So, 2j cancel out, and I am left with a sin 4 alpha divided by a sin alpha. Okay. So, if there are 4 sources, then pressure at a point P is equal to a sin 4 alpha divided by sin alpha. And what is alpha? Here alpha equals, so we had defined earlier, it is omega d sin theta over c and if you replace omega by, so this is actually 2c, and if you replace omega by 2 pi f, then this becomes pi d sin theta over lambda. So, that is the definition of alpha, and in this expression a should not have been in the denominator, that was by error. So, that is the expression. So, what we have done is we have developed expression for 2 sources and 4 sources. Similarly, we can develop expressions for 6 sources, 8 sources and so 8 sources and so on and so forth. So, in the next class we will actually generalize this relationship, and then we will see what it where does it take us. So, with that I am concluding our discussion for today, and we will meet once again tomorrow and continue our discussion. Thank you.